So today's topic, we are going to start to look at how we can prove triangles congruent. And there are 5 different ways that we can prove triangles congruent, but for today we are just focusing in on one, which is the side angle side triangle congruence, or you're going to see we're going to abbreviate it by SAS. So what does that mean? So that means 2 pairs of sides and the included angle are congruent. So I have 2 different triangles and I can see 2 pairs of sides. So here's one pair, here's the second pair, and then the included angle. So this included angle, notice where that's sitting. Your included angle will always be the angle in between the 2 sides of a triangle. And in this case, because we're trying to prove triangles congruent, it should be the congruent angle sitting in between the 2 congruent sides of the triangles. Okay, so we're going to take a look at perhaps how I could look at 2 triangles that are congruent and what kind of transformations we could do. So thinking of our definition of congruence, there should be a way that we can use rigid motions being things like translations, rotations, reflections. And we're going to put them together so that I can see these triangles could sit one right on top of each other and they would be congruent. So if I'm looking at this first step, so these are the 2 triangles that we saw up above. And what we're doing in this first step is I'm taking the 2 angles, the 2 vertices of those angles, and we're moving them towards each other. So once they're moved, all right, we're starting here on this first picture and down here, that's the end of the movement. What we can see, we've just slid that picture. So step 1, we're looking at a translation. So then step 2, it looks like, well, if I could move this point C together, I could then have my sides touching. So what I'm doing, I'm actually rotating it. It's centered at A, and I'm rotating my triangle so that C double prime and C touch each other. And then when I'm looking at this last step down here, step 3, if I could take the triangle and reflect it over this line AC, I could now see that those 2 shapes would line up one right on top of each other and they would show that they are actually congruent. So if I look at question number 1 on this page, it says, which of the following triangles can be proven congruent based on the side angle side case? Now, all of these triangles can be proven congruent. It's just we're going to try and see which one is side angle side. So if we're looking at the first one, again, if I'm thinking side angle side, just like the way it's written, that angle has to touch both of those congruent sides. So in this case, I see a side, I see another side, and then again, I see that included angle in between them. So I can say yes, these triangles are congruent by side angle side. This next picture to the right, okay, again, if I'm looking at the sides, I see one set of sides, I see a second set of sides, and that included angle would be this angle here. Now, it's not marked, but I know that those angles are congruent because those are vertical angles. And since our vertical angles are congruent, I can say, yes, again, these triangles are congruent by side angle side. If I look at this third picture, so again, we're just thinking side angle side. If I'm looking for side angle side, I need 2 sets of sides. I only see 1. I actually see 2 sets of angles. So I would have to say, no, it's not going to be side angle side. But in fact, what it will be, and we're going to learn this a little bit later on, is this is going to be the angle side angle case. In this last set of pictures, again, same thing. If we're looking for side angle side, I'm looking for 2 sets of sides congruent, and I only have 1 set of sides. So again, I'm going to have to say, okay, no, they're not congruent by side angle side. I could say that they are congruent by angle side. And again, we'll get to those other methods. We're going to get to this a little bit more, but just so we can start to recognize what's congruent. Okay, so what does this look like in a proof? So in a proof, just like we have done before, you're always going to have your statements and your reasons. And we always start our proof off with the given. In this case, we have two different givens. We have the fact that angle 1 is congruent to angle 2, and that side BC is congruent to side DC. So if I look at my picture, here's angle 1 congruent to angle 2, and side BC is congruent to DC. So it's always a good idea to mark your picture with the given once we get going. Okay, and we're trying to prove the triangle's congruent. So I have to find another side to say they are congruent. And the one side that we use quite a bit, this is kind of a new little statement here, is this side. I can see how the side AC is not only in triangle ABC, but that side is also the same exact side, same exact length in triangle ACD. So I can say, yes, in fact, AC is congruent to AC, and the reason I can say that is because of what's called the reflexive property, saying something is congruent to itself. So looking at these triangles now, sometimes I like to do check marks, sometimes I like to count, sometimes I like to label, just different things that we could do. I always think to myself, I need 3 congruent statements before I can prove triangles congruent. So I need at least 3 congruent statements before we can prove triangles congruent. And those 3 congruent statements should be the statements saying, I have a side, I have an angle, and I have a side. So if I can say, yep, I got those 3, then we can go on to prove triangles congruent. So I have triangle ABC is congruent to triangle ADC, and our reason here is because side, angle, side. Okay, so then it says describe the rigid motion that would map ADC onto ABC. So in other words, how can I get this triangle over to the other triangle? Well, if I look at this line here, line AC, that looks like a really nice line of reflection. If I reflected that triangle over AC, those triangles would map up to each other. So I could say in this case, a reflection over that segment AC. We're going to try one more proof. Okay, so just like we said before, we're going to start our proof off with our givens. Notice our givens are a little bit different. They didn't tell us anything was congruent this time. So in my mind, I'm thinking, okay, I need 3 congruent statements before we can actually say these triangles are congruent. So I am getting some information here. So I have KM and JN bisect each other. And immediately in my mind, I'm thinking bisect. Bisect means cut into 2 equal parts, which is awesome because I'm looking for equal parts. So if KM bisects JN, that means JL and NL are congruent. So I'm going to write that down. JL is congruent to NL. And if I also know that KM is being bisected by JN, well, then that means KL and ML are congruent. Now here's the nice thing with proofs. Doing the same thing, using the same reason at the same time. So I'm just going to write this all in one step. If you didn't, no big deal. If you want to save some space, save some time, because I'm doing the same thing at the same time with the same reason, I can make it all step 2. And the reason, well, it's coming from bisect. So I can say bisectors create 2 equal parts. Okay, so I've marked my picture. Maybe I do a quick little check mark. So I have 1 congruent statement. I have 2 congruent statements. I'm looking for a 3rd. I've used up my given. I have nothing more in my given. So maybe I go to my picture and I say, well, do I see anything? Are they positioned in any which way? And I can say, yeah, I see those are vertical angles. And we know no matter what, vertical angles are equal. So we can say KLJ J is congruent to angle MLN. So we have angle KLJ congruent to angle MLN, and our reason is vertical angles are congruent. So it's marked on my picture. There's my third check mark. I look at my picture and I say, does it satisfy that side angle side relationship? And it does. That angle is included. It's in between the two sides. So now we can go and say triangle JKL is congruent to triangle NML because of side angle side. And now if we want to see that rigid motion that would map the triangle, so I need to get this side here with 2 markings onto this side with 2 markings. So I have to do a little bit more than just a reflection. Perhaps what we could do is if it's centered at L, I could rotate this 180 degrees around and those 2 triangles would map up onto each other. So for this case, I could say a rotation of 180 degrees, and we always want to tell you the center point, so I'm going to say centered at L. So that's just an introduction to proving triangles congruent. That was only 1 out of the 5 ways we can prove triangles congruent. We'll practice this more in class and learn the other 4.